Hello everyone and good morning! Welcome to Let's Do Research with Dr. S. This is Dr. Sarah Namoko and I am your friend in your research journey. In this video, we shall be talking about sampling techniques. Whatever lesson that you will learn from here is very important and useful as you write your methodology chapter of your thesis or dissertation. Okay, for the random sampling approaches, we have simple random approach. This approach is one in which each and every member of the population has an equal and independent chance of being selected. What is its advantage? It reduces the potential for human biases in the selection of cases to be included in the sample. However, there might be difficulty in gaining access to the list of a larger population. It is timely and it is costly. Why? Especially that we have privacy data law. These offices cannot disclose the identity of the people within their institution because of the data privacy law. Therefore, doing sample random is difficult because of this disadvantage. Now, I would like to share with you some techniques in doing simple random. The classical one is the fishbowl technique. Okay, when we do fishbowl technique, you have the sampling frame, you list all the names of the people, of the persons that you want to choose, and then put them inside a bowl, and then randomly pick the number of participants that you need in your study. That is the fishbowl technique. In this video, I would like to share with you aside from the fishbowl technique, I am going to share with you in this video some random number generator that is available online. Okay, watch out for this. One of the online random number generators that I would like to share with you is the random.org. Here, you just need to enter the number of all the participants. But friends, be sure that you have a sampling frame. Remember the sampling frame I told you about? Suppose this is you have 100 persons in your population. So you put 1 down to 100, and then each corresponding number has the name of the participants, the contact information of the participants, because you are going to contact each of them when you do your study. Okay, suppose you have already done that. Okay, and then you have encoded here the sample. Okay, all the numbers that you need, the numbers of your sample, of your population. So you have already encoded 1 up to 100. Okay, so after you have encoded the numbers on the number of the participants, you click randomize, and then the random generator will give you who will be these 80 people that you need to choose. Okay, they have arranged it from 1 to 10, and then the first 80 numbers that they have identified, these will be your respondents. Another random generator that I would like to share with you is random number generator by Andrew Hedges. Here, it's easy because you just want to say, I want 80 people from 1 to 100. You can choose sorted or not sorted. It depends on you. And then you say get random. And then the internet will give you the numbers that you will use as your respondents of the study. And given that, for example, respondents number 32, the name is name number 32. Okay. That's it. So this is an example of simple random sampling. Another approach to random sampling is the cluster random sampling. This is done to study a number of intact existing classes. Take note, class. Cluster random sampling is intended if you already have an intact and existing groups or classes. The advantage of this is that it requires fewer resources, fewer administrative and travel expenses, and therefore it is generally cheaper. However, this approach is prone to biases. Therefore, generalizing the findings to the population could be biased as well. I'll give you an example to this. Suppose you are interested to investigate the effect of modular class mode to the academic performance between BTLE and BSE math students of the College of Education. Now, suppose the Department of Technology has 12 sections, that is, sections A to L. And the Department of Mathematics has 9 sections, that is, sections A to I. So what you are going to do is write the number of sections, the name of the sections on a piece of paper, roll them so that you don't have, you cannot influence your choice of respondents. So you write section A, section B, and so on for science, for the Department of Technology. And then for the Department of Mathematics, you write section A, B, C until section I. And then you choose one from technology and one from the mathematics department. And then whatever section that you have come up, say for example, in technology, you have picked up section H, and in mathematics, you have picked up section C, and this will be your cluster sample. You cannot say, oh, I'll get 2 students from section E, 5 students from section B, 6 students from section C, and so on. You cannot do that because the students are already in their existing classes. So if this is the case, you do not do simple random sampling, but you are going to do cluster random sampling. Is that understood? Okay. The last approach for random sampling that I'm going to share with you is stratified random sampling. This is a process in which certain subgroups or strata are selected for the sample in the same proportion as they exist in the population. The advantage of this is that it provides greater precision than a simple random of the same size. The disadvantage, however, is that it requires more administrative effort than a simple random sample, and the analysis is computationally more complex. Say, for example, you are going to study the effect of flexible blended learning towards the academic performance of ABC University students. This university has 5,000 students, and according to Craigie and Morgan, with a population of 5,000, you need a sample of 357. In another video, I will discuss with you how this computation is done, okay? So how do you do that? Say, for example, this is ABC University, and they have 5,000 students. They have 3 colleges. The College A with 1,800 students, College B with 2,000 students, and College C with 1,200 students. So, you need to choose the sample proportionately. If you don't do the stratified sampling, most probably you might choose most of the respondents from College A and then only a few from College B and College C. And this will lead to biases in the findings, in the results of your data analysis later on. So to avoid biases, we need to proportionately choose in strata the respondents of the study, the sample of the study. So how do you do that? We divide 1,800 by 5,000, so we get 36% from College A. In the same way, we divide 2,000 by 5,000, therefore we will have 40% of the sample from College B and 24% from College C. In this way, according to Craigie and Morgan, with a population of 5,000, you need a sample of 357. So how do you do that? 357, because that is your expected sample, right? 357 times 36% from College A, then you will have 129 respondents. Actually, when you compute this is only 128 point something. but you don't have 128.5 number of people. So you round that off to the next number. That means you need to have 129 respondents. For College B, with 40% times 357 sample, then you will take 143 respondents from College B. And from College C, with only 24%, you will take 86 respondents. Okay? So this is strata, meaning that you are going to stratify, you are going to divide the population according to its strata so that you can take the number of sample proportionately. That is why it says that stratified random sampling provides greater precision, because you chose the sample proportionately according to the size of the population. However, because of the many steps that you have to undergo, it requires more administrative effort and, of course, more complex analysis later on. Now, I would like to bring you to the references of which ideas in this video were referred to. Again, this is Dr. Sarah, and I hope you enjoyed this video tutorial. Thank you and bye-bye!